Ladies and gentlemen, aspect-oriented programming. We saw some details of aspects last time. So I provided an example aspect that we were looking at in Aspect J, one of several aspect languages out there. It's an aspect language that runs with Java, yes, but it also runs in the JVM machine in general, and it can run with Scala, is my understanding. So you can actually use it to weave things into Scala or probably other JVM languages. And we saw that we could delineate point cuts where we want to weave in some advice, some code, right? And for each point cut, that specifies a join point in the underlying program. One of these kind of significant points of activity. And we could specify with advice that we want to weave some code in before or after those join points or around, etc. And what code we want to weave in. And the code that we weave in could extract some information about the context, like about what's being called, and use that in its reports. So that's an example of an aspect. Another aspect that I've asked you to create for assignment 3 is one, man, I'm tempted to show you. It's one that kind of looks like this. Okay. I better not tempt fate. Time is short, and but I had a demo of it yesterday for the markers just to show them what I'm looking at, and it displays Conway's Game of Life visually in Java Swing. Another aspect that I asked you to create reports the number of live cells at any one time. Another one reports the step count over time, right? Those are all aspects. They take a specification of what you want to weave into the program, where to weave it in, and they weave it into the program. Sometimes that weaving can be done into the source code of the Java, or Scala, actually would be a Java in this case. But other times it can be woven in at load time, when actually the code is being read in, the Java code is being read in from a jar file. You can weave it into that. So it does not require you to have access to the underlying Java code, to be clear. You can actually weave it in without having direct access to the Java code, just having access to the bytecode, a jar file. With caveats, you need to be able to specify where to weave it in and do so with confidence.
So you need to know the interface that has function names.
Yeah, you need to know something about the function names associated with that code. And at the same time, I have seen students for projects in this course use aspects to weave into third-party libraries, for example, or third-party Java applications. They weave in some code that, for example, tracks where the mouse is over time and does a heat map of that for user interface research. So it weaves into arbitrary Java code, and it does so by linking in with Swing, with the underlying graphical calls, which are common across these, not truly arbitrary Java code, but large swaths of Java code that use Swing or what have you. Okay, so very powerful methods. Do you see? Well, I hope you see opportunities there. We can have a separation of concerns. We can capture what we want to display from our program, for example, graphical output, reports of step counts, counts of cells over time that are live. We could specify that separate from the engine, the thing that actually does the computation, the thing that's performing the simulation itself. And by separating those, we could change one without changing the other. Right? We could change the engine so it accepts more types of rules, or so it has a more general sort of set of possible spaces of rules that can simulate, Or we could add in over time more visualizations and swap them. We can add in a visualization or add in a mechanism that reports, the command line parameters passed and reports on the performance. So it's a very nice way of separating out concerns. On the one hand, involving here what information to print out from the simulation itself, and because we may be capturing features that are cross-cutting in the underlying code, we can often consolidate the code, and as that other code base evolves, the code is automatically woven into the right places, even as that code base evolves. So that's the idea. There's opportunities there. There's opportunities for improving modularity, improving separation of concerns, having more robust adaptation to a modified code base. But do you see any dangers? Do you see any dangers here coming from aspects? Having them woven into your code? Yes.
Me?
Yeah, either of you.
Okay, well, yesterday I was dealing with the argument array of strings, and I realized that you could go in and change values.
Yeah. You could change values in the code into which you are weaving. Could that pose risks? Yeah, it can pose risks. Big risks. Janelle, did you have something too?
Kind of along the same lines as you can kind of betray the user expectations by changing the behavior of certain things, like maybe a function is called within a function, but you interrupt that somehow.
Yeah, good. So with the round advice, we're not using it here, we're using before and after, but a round advice can allow you to sort of surround a call and to electively perform the call or not, based on the whim of the aspect, based on the choice of the aspect. You can change the behavior of the underlying code in some pretty profound ways. You could substitute a whole bunch of logic for code that's already there. You could update values, update data structures, a whole lot of things that you could do. Now, if this is your code that you're modifying, and you're keeping track of that, it raises hopefully fewer concerns, so there's still complexities. If you're doing so with other people's code, there might be real challenges. What challenges might there be?
They might make changes to a function that you never notice.
Yeah, they make changes. Maybe you don't even have access to their code base, and you don't notice suddenly that your method, your advice are not being woven in properly. Other things. Their code could be counting on invariants, behaviors that are violated by your code. You're going and changing something, they're reasoning about it carefully and say, okay, there's no display update between this point, and actually your code is weaving in something where there is a display update. Now, all of those things that I asked you to perform, this example that I gave you, which prints out what's calling one. I think Tushita had a really nice version of this that actually timed the thing that was the method call, so you could have time before, time after. You could get elapsed time in principle, if I'm not mistaken. Something I saw, which is nifty. In other cases, we're observing the count of live cells. We're doing a display of the cells. All those things share a certain characteristic. What characteristic do they share in terms of danger?
They don't have side effects.
They don't have side effects. They're all epiphenomenal. They're observing the underlying process. They're collecting information about it through parameters. Through parameters to the calls. They intercept run scenario, for example, or update space, and they capture the method arguments being passed, and they use them in their own code. There were some examples of this in the code that I had in those videos that you'll want to use in your assignments for sure. But ladies and gentlemen, what they didn't do is they didn't modify the behavior of the code that they were woven into. Because there be dragons. That's where it gets particularly risky. If you're just observing the underlying code, there's still issues that underlying code might change. They might change a method from this name to that name, and your code doesn't get called properly. But there's less risk that you're going to screw up that code. You're going to break that code. But this brings up an important point, and a practical point, as I tried to be in this course. Where practical orientation I've tried to adopt in this course. And that is, what's lacking here? If you wanted to have aspects used with a code bases, under your control, not under your control, if you wanted them to use in a well-structured, reliable, robust fashion, what do we need? What do we need? I'll give you a tip for the final exam. If I ask you, what do we need? You could roll a dice. Chances are it'll be one of a couple of answers. And the answer here is, what do we need to provide guarantees? What do we need to provide contracts? We need specification. Okay, that's like one on the dice, okay. Specifications. 2 on the dice is Scala. No, I'm joking. But 3 in the dice, abstraction. This is actually getting pretty good. Okay, I won't go down that direction. We have too much to cover. But specifications. We need some sort of contract that will say what the method is going to be called in the underlying code base so that we can weave into it with confidence. If we are weaving in aspects that are observing, we need some way to have guarantees that they will be reliably docked at the right place in the code base to observe the things that they need, so that the method arguments that they count on won't be changing, for example. This sort of information is available in this way when the advice get woven in. And we need some way of, if we're making side effects in the underlying code, of having specifications in that code that are cognizant of that. Now, how many people, for your aspect code, how many people here are doing work in Eclipse with the aspect framework in Eclipse? Okay, a couple people. One thing that's nifty about the aspect framework in Eclipse, although you might not have chosen that word to describe it, if it's not nifty, it's cool. I'm told at one point it was called sick, but it's a very healthy thing. You can actually, with the Eclipse framework, see where code is woven in. Okay, Janelle got that one. So you could see where the code is woven in. You could see a visual indication of using a little marker on the left-hand side about this is where aspect code is woven into this code base, which is really helpful for knowing where it is and where it's not being woven in. But it's still not a contract. It just gives you a bit of a high level up that basically there's details here that you're not seeing, and you want to be aware of them. Because it's a little bit disconcerting to look at code and not know, are aspects being woven in here or not? And Eclipse does a pretty good job, the best I've seen in any environment, for alerting you to the fact that aspect code is being woven in at this point. And that allows you to go look at that aspect if you want to, because much of abstraction is about hiding details. Abstraction is about achieving generality, flexibility, by hiding a lot of details that separate cases. And here, we're hiding details about what's woven in here, but with abstraction in general, we like to know there's something there, so if we want to, we can go find out more information about it. So that's an important part of the aspect experience, is being able to know, okay, something is woven in here, what it is, so that I can go find out more detail if I want to do so. Can.
I sent an email to actually.
Uh,
I haven't read it. So when we run aspects in Java,
mm.
what is the point card for the simulation start and the end? Because we all have a different
Good.
solutions. And it will delay a little bit of the running compiling time if we run in Eclipse. It's normally longer, 2 seconds or 3 seconds longer than you run it.
Yeah, thanks for asking. I'm not actually worried about that
But what is
side.
full cut point
okay.
and the after cut point?
Yeah, right.
That's the
Right. Yeah, so one way to, in Java code, the code that I gave you in Java, there's this simulate method. Okay, there's a method called simulate. And that simulate method is actually used to sort of kick off the simulation, where these arguments are the arguments passed on the command line. So that's a good place to intercept it. You could capture it at the call to simulate from above, or you could capture it in what's called execution of simulate, which means basically just inside a simulation gets kicked off. And then you'd have access to these arguments, which are the command line arguments, which is useful for one of the subproblems, printing out a run log. I'm not worried. Thank you for asking about the runtime, 3 more seconds. It's good that you're thinking about those things with care, but you don't have to worry about that, okay? I welcome use of aspect data in Eclipse is fine. And in some ways, it gives a more fulsome aspect experience, okay? Okay. So ladies and gentlemen, with aspects, you'd like to be able to know where they're woven in. You'd like to have some sort of contract that guarantees that their use is bounded and that certain things they rely on and certain things that they perform are well defined so that the code bases of the aspect and of the underlying code base could evolve with appropriate ease for their implementation while still providing the guarantees to each other. Again, we don't want modularity to mean that everything is a solitude unto itself. It can't know anything about something else. We don't want abstraction and encapsulation to mean I can't know anything about what you do. I need to know something about what you guarantee, but leave a lot of details of the implementation free for you to evolve your side of things. And so it is with aspects. You want some sort of aspect contract. We don't have time to go into that in this class, but you want a contract for aspects. You want a set of guarantees. And the way we do this in current situation is by providing specifications, either English language specifications or increasingly in systems like Z++ or Alloy, specifications that are actually machine understandable. It can be used for optimizations, etc. Okay? Aspects, ladies and gentlemen. A powerful technology, one that has some very significant uses out there in industry, and one whose ideas for separating concerns, cross-cutting concerns, are being addressed additionally by added technologies beyond Aspect J, and in fact by a set of aspect technologies that are out there. Useful, but it's like a power tool, ladies and gentlemen. Power tools, chainsaws, brush cutters and so on, they're really, really powerful. They can save you a lot of work. They can be just the right tool for the job, but they can also cut off your arm. And aspects won't cut off your arm, but they can cause you sleepless nights if you're not using them with care, if you're not using them in a well-defined, principled, guaranteed way. Specifications are one of the best ways to try to achieve that. and visual feedback and things like Eclipse can also help. So use tools like Aspects with caution and care, not with abandon. Okay? Part 1 of Mission Impossible. Any questions about Aspects? Any comments about Aspects? Any screams about Aspects? Okay, great. So we will proceed on